Start again. Okay, so my name is Brian Meany. You've seen some of our team here already this week, so the likes of Arcadius, or Cali, as we know him better, and here he is. They'd sit within a team we have in EMER. So I lead a lot of the architectures in relation to where we're going, what we're doing. So one of the things we wanted to do today was, obviously 90 minutes after lunch is absolutely ideal. So number one, I'll try and keep you awake. I don't promise. I'll do my best in a dark room. Number two, we're going to give you a little, normally we probably wouldn't do something like this, but we want to give you an idea of our thought process and what we're thinking and where we're going. And this is an area that the guys asked to present on. Don't worry, I walk all the time. Some people think I need to go to the toilet. I'm fine. It's just I tend to walk. I did fall off the stage last year, so they put no stage this year. So I've fallen off stages. I've knocked down plastic plants. I've done everything, but I do need to walk. So don't worry about that. So what we hope to do, it is quite a long session. I'll try and keep it as interactive, but there is a clear message as we go through it. So very much what I want to do is talk a little bit more. So Carly started giving very specific stuff yesterday about virtualization. I just want to kind of give what we're seeing in the market, where we're going, and the sort of interesting topics that we're seeing. I'm then going to talk about a thing called edge transformation. So the industry is full of initiatives and forums and standardization bodies and open source things, and they're all fantastic, but they're all very confusing as well. And so we're just trying to say what are the key requirements we're seeing of some of the edge transformation. Then I want to give you a view of what we're doing, where we're going, where it's kind of the market that we are now going after. So it's developing some of the capabilities. So I hope you all understood Callie's presentation yesterday, because we're going to jump from that to what else we're actually going to be doing. So if we actually look at it here from the point of view of where are we at with virtualization or SP virtualization. A lot of people like to refer to this as NFV, network functions. The S is a lot of people like about the S, virtualization. But very, very clearly, we've seen it for the last number of years. And anyone who has Gartner or seen Gartner charts, they talk about, the peak of inflated expectation. That's exactly where NFV was initially. Everyone expected the sun, moon, and stars. We virtualize everything. The world is a better place. And then as an Irish guy, I'm Irish, right? We love this thing that we all fell into, was a thing called, a trough of disillusionment. And that's where NFV really went, right? It was like, God almighty, it doesn't do anything of the things we actually thought it was meant to do. And now what we're in, we're going to a kind of a slope of enlightenment. I love these terms. I think where do they get them? I don't know. But very, very clearly, where we are, there were challenges with NFV. There were challenges, and we did go through different iterations. So we went from, completely a la carte, and a la carte is mostly where a service provider said, I'll build everything myself. And what they quickly realized is, putting all these things together is very complex. We then went to vertical solutions, and vertical solutions really was a use case and everything underneath it, you put as a solution. But that had problems as well, because how do you scale it? How do you put on other VNFs? How do you make it multi-vendor? Very, very difficult. So where we are now, and where most service providers and SPR is, I need a common platform, and on top of that common platform, I actually can put multiple VNFs, multiple use cases. And that's the model that really is gaining quite a lot of traction. So in the last 12 to 18 months, although I've been involved in NFV for maybe 5, 6 years, I know I look very young to be that long in NFV, very, very clearly, we're starting to see a lot of traction. And again, there is a lot of things going on. So while there were challenges around process, challenges around orchestration, challenges around interoperability, we are finally getting to the stage where virtualization is hitting the requirements. And again, I wanted to put in this slide. It's not a public slide. Not everyone here is publicly referenceable. But you must realize that there's more than just marketing behind this. And I put in 4 examples here from around the world that we have actively been involved in. And if you take some of them, I mean, if you look some of the benefits we've seen in virtualization, if we look at the Vodafone example, we're talking about a terabit of bandwidth in a purely virtualized environment. The most impressive thing here is from the time equipment arrives on site, it's 72 hours SLA to going live. Anyone involved in SPs before, that could be 2 months, 3 months. There's some service provider, that could be years. So you really, really begin to realize the benefits is not virtualization. The benefits is actually the efficiency of operations, the efficiency of orchestration. Taking other examples, very much in a Mobile World Congress this year, Rakuten. And we'll talk about this later. Japan, obviously, but what this are, everyone always wonders who's the sponsor of Barcelona, and Rakuten is across it. That's who Rakuten are. Very, very much about how do we virtualize the whole radio environment? How do we push that intelligence out? They're doing things of virtualizing the radio and access that a lot of people say wasn't technically feasible. So now what we're beginning to see with a number of these examples is pushing the boundaries of technology. So we really need to begin to think how we actually support this. And if we look at the likes of Deutsche Telekom, mentioned yesterday, but I want to bring up, they have a company they acquired called Mobile Edge X. Very, very interesting, because this is about consumption. How do you consume this? How do you consume it? How do I develop APIs? So you hear the guys talking about later on about NSO and APIs and model-driven. This is taking it to the next level. How do you consume this from end to end? How do I develop APIs to make sure that the app developers can consume? So there's very, very real examples here. And we have a changing market. There is a major change going on. So we talked about virtualization. Virtualization itself, is just something that happens. But what we're actually seeing now is there actually is some major changes in relation to how people view these networks and the changes that need to happen. So very, very clearly, customer experience is beginning to come very much to the forefront. And when I talk about customers, you'll quickly begin to realize that the market, especially in EMER, is very consumer-driven. But what you'll actually see is more and more as we go forward, it has to shift from consumer to what we call vertical markets. And we've spoken about it for about 10 years. We've kind of given lip service to it, but it actually needs to happen now. Because if you actually look, there's a very, very good report by the EU Commission, well worth reading. It's actually very, very well written. Some of the analysts' stuff can be a little ropey. This is very good. And when you look at it, you actually see that by 2025, it's vertical markets that will actually be a major, major component of your revenue. To hit vertical markets, you need to offer strict SLAs. A very, very key component to this will be an evolution towards things like 5G. But what's coming very much to the forefront is customer experience and words like low latency. If I was here 2-3 years ago, latency tended to be a very technical term that technical people loved. You will now see latency coming into marketing. Latency is beginning to become very, very key with the end user experience. And so latency, I'm going to bring it up later, is starting to become to the forefront. In a lot of countries in EMER, we've started to have what I call beauty tests. And beauty tests are very much, how good is my network? And before we used to be absolutely obsessed with download speeds. That's changing. It's now, what's the experience? What's the app performance? How is it? And you will find that when you reduce latency, the app performance becomes massively, massively. And in Germany in particular, who lead the way in this area, this becomes very, very crucial to how your network is perceived. And, people say throw bandwidth at it, will fix it. No, it doesn't, actually. You will see there's multiple components. And I'm going to bring this up as we go through. So what are the kind of things that we're beginning to see? And I'm going to slightly introduce them. Some of you will be familiar with these, but there's 3 major kind of technology transitions we're seeing at the moment. First one is decomposition. And decomposition really is about, we look at how we build traditional entities. And if we take things like BNGs, or we take things like, some network functions, we tended very much to put control and user plane or data plane together. They were all one entity. We put them in one box, and we tend to manage it as a single entity. What you'll see more and more now is we're decomposing them, where we're taking them away. And we'll mention this later. We're actually building them differently as well. So when you look at them, you'll begin to see that there'll be things like control plane centralized, user plane distributed, and this is all part of this evolution, which a lot of people talk about towards containerization or to containers or microservices. It's about we are starting to build these things very differently, so you can pick and choose where things are going. Obviously, as well, what we're seeing massively is the actual disaggregation. And disaggregation is that you're kind of removing the linkage between the software and the hardware. And again, that could be on, compute hardware, that could be on Cisco-specific hardware, that could be on Broadcom, that could be on anything. But there is the evolution towards this. And again, how we provision it, how we optimize it becomes very, very clear. And then very much as well, and which is very important, while we've spoken about it for many years, we are now beginning to see that 5G is kicking off a kind of a real evolution towards convergence of mobile and wireline and access technologies in general. And so, again, really has been realized. Just to go through some of the things, because there's a lot of stuff in the industry and being termed and what it actually means, there is definitely this whole thing that you'll hear about called CORD. And CORD is very much about, CO transformation. It's a term in Europe we're not very good at, because the term CO central office is not really a European, it's more a US term. But what we are seeing is this kind of transition. So the transition really is about how do I have an open platform that will allow service migration and creation. And I think that is very, very key when we look at it. So what it's about taking services to parts of the network that we probably don't have those services today. So it takes virtualization, it takes SDN techniques, it takes data center architecture, and it's moving it out to a point of the network where you get agility. And we definitely are seeing that in MER. So definitely, this is something which we're beginning to realize and beginning to see in the last 6 to 12 months. There are standardization forums called Linux Foundation CORD. Now, what I would say about these, they're good to read, especially if you have trouble sleeping at night. But definitely you will see that there are open source projects. This is probably one of the biggest ones. You'll see that they'll have recommended components, so things like ONOS as the SDN controller. But what I would say is that things like Linux Foundation CORD is an instantiation or an example of how you could do CO transformation. So, very, very key is that, just to be doing CORD or to be going down the road of CORD doesn't mean that you have to use these specific examples. So, we are already doing CO transformation in many accounts, but what you will see is that we will use different components, different capabilities in different parts of the solution. So we will use a mixture of open source and product, and you'll see this later. So just doing kind of a CORD or going or conforming to CORD doesn't mean that you have to use those specific components. The second thing that you'll hear quite a lot about is this thing called MEC. And MEC, to a lot of people, is mobile edge compute, but actually it's not. It's multi-access edge compute. So it initially did start as a mobile capability, but what you will see is this really is about, how we take services and we move them closer to the user. And this is very, very key because a lot of people misunderstand MEC. Some people say MEC is this magical thing where you put a server very close to the user and magically everything improves. That's not what MEC is about. MEC really has three major use cases in the MER. The big one is the one I mentioned, latency, reducing latency, the effect of latency on the consumer. That is the big one in Europe. In the US, they tend to like to have this offload option, because a lot of the times they don't own their backhaul networks, or there's a lot of contention in their backhaul networks. It is still a use case in the MER to offload, But mostly offload today is about pushing content out further rather than purely offloading to the internet. So a use case, we are seeing certain specific markets, but very, very clearly, data reduction is starting to become very, very key. You'll see later with Patrice and the team extracting information, taking information, storing it. There's an awful lot of information, and how do I get it back? So what a lot of times we're seeing in these architectures is that a lot of the gathering, a lot of the storage is done in a more remote part, then it gets summarized and sent back. So you'll very much see right across EMER the use case for those three areas in relation to MEC. And so it is definitely what we've been seeing the last 6 to 12 months, something that is showing quite a lot of traction. Again, what's in the standards? In the standards, we have ETSI-MEC. Now, ETSI-MEC, to a lot of people, is confusing. And ETSI-MEC, in general, when it started, was more what we call bump in the wire. And do people know the term bump in the wire? Bump in the wire is basically saying that I don't actually interfere. I de-encapsulate, I do something, and I re-encapsulate. So that basically means that I don't interfere with any of the protocols. I de-encapsulate, I re-encapsulate. So that type of technology as such has been around a while, but to many operators in Europe, there's problems with that technology. The problems with that technology are mostly about what happens if I have things like handover, it affects it. How does that affect lawful intercept? So in Europe, we're quite strict in security, and even more strict these days. So bump in the wire technologies, because you're in cap and decap, it has serious question marks, again, around security, lawful intercept, but also charging. It's very hard to get quantitative charging. So what we've seen in EMER, and actually ETSI-MEC is starting to go in this direction again, is we're starting to see that it isn't really a bump in the wire technology. It's where you take a session in and you terminate the session and then you do something with it. Now, I know I'm using very simple terms there, but I'm doing it intentionally because a lot of times we use very, very long words that nobody knows and we all nod along. But that's really what it's about. It's about taking in, terminating a session, be it a wireline session, be it a mobility session, doing something to it and letting it continue as an IP packet. And so there is the capability of terminating. What you will see in relation to this, and there's general acceptance to this in EMER, is it's a 3GPP-based architecture where you actually do a kind of a termination of the user plane in a more distributed manner. To a lot of people, this is referred to as CUPS. CUPS being control user plane separation. It's where you separate the control plane and the user plane. You push out the user plane and you terminate it. And that's quite key because there's two very competing technologies. The winning technology today is the termination. And even ETSI-MEC are now going in that direction as well. I think that's quite key because that will lead to why we make some of the architecture choices later. What other things are happening? You'll start to hear people talking about mini, micro, less so in EMER, but what you will start to hear is a thing called network data centers. And network data center seems like a contradictory term, but it actually isn't. It's basically where you have your traditional data centers that tend to be very centralized, tend to be very large scale, tend to support an awful lot of what we call east-west traffic, so a lot of traffic within them. This is probably one of the growing factors we're now seeing the last 6 months. It's where you now have service providers who need to build network data centers, which basically mean we're building data center-like technology in a different part of the network. Do not make the fundamental mistake, which many people do, that you try and build them in the same way. There's fundamentally different requirements between a centralized data center and a network data center. And we're going to go into this in more detail. They tend to be north-south. What comes in goes out. They tend to be very much about NFV or containers. They tend to be the newer applications, and they tend to be more distributed. They tend to be smaller. How you build these is fundamentally different. And I've spent the last 18 months looking at this. You know, I've learned the hard way. There's ways not to build these, there's ways to build these. And then comes to the whole thing of, why didn't I use the terms cord or MEC in my header? The reason I didn't do that is because I think those are individual initiatives. I think they're very specific to parts of the network. But what we are now doing a lot of work is a thing called service edge transformation. And service edge transformation actually takes those things together, but looks at it holistically from end to end. So MEC tends to a lot of people to be very distributed. Cord tends to be a certain part of the network. Service edge transformation is where you look at the service and you decide what part of the network should it go in. And so it takes things like virtualization, it takes things like decomposition, which we said, but it also has placement. And that's something that service providers couldn't do for a long time. The service, most of the time, was placed in the part owned by that service provider, owned by that department, and they had no choice where it actually went. So what you'll see with service edge transformation is that it's now saying, I have this service, where does this service go? Where do I actually place it in the network? Do I virtualize it? Do I not? Do I decompose it? Do I not? And very, very key is that this word edge is misused. You know, everything is the edge. So very, very key, we are talking very, very specifically about the service provider multi-edge. You talk about a lot of cloud players like, you know, you can choose the likes of Amazon, Google. They talk about the edge, but their edge really is quite centralized. You know, so very, very clearly, what we're going to dive into a lot more detail is where is this service provider multi-cloud edge, multi-access edge going to be within the network? And again, very, very clearly, you'll see that even IoT and enterprise, where they deem the edge to be is different parts of the network. One of the outputs, and this is a very key output, is that when we look at the edge for the service provider, you will see two deployment factors today. And a number of service providers initially said, we will never go into a premise-based solution. And actually what we've done after 18 months of analysis is actually we're beginning to see that service providers will look at both these. They will look at both a network-based distributed edge, and they will also look at a premise-based edge. So more and more what we're beginning to see is that for certain services and certain capabilities, and I direct you very much towards even 5G. There's a thing called ultra-reliable low latency. Terrible term, but that's what it is. They keep these terms complex, so it gives people like me a job to try and explain them. You will see, to hit the requirements of those, a lot of service providers are beginning to realize that they won't actually be placed on the service provider network, but they will control it on the enterprise. So things like, you know, transportation verticals, things like, you know, we will see that those verticals will need to be placed at a specific. But today, we are definitely going to look very much at what the actual network-based capabilities will be. I will highlight certain things that they will need to be a premise-based. We do have premise-based solutions as well. Again, we can focus on those at a different time. And then terminology. We do need to agree terminology, and I need to give you an example of what sort of terminology we are talking about. Today, a lot of services tend to be based around regional or central data centers. They tend to be areas of the network. In generally MER, you're normally central data centers is normally 2 or 3. Regional data centers, you normally have 8, 10, 12. What we are now beginning to see is what we have a thing called edge. And edge is a CO, normally US. It's normally called aggregation or metro in Europe. And this tends to be a part of the network where you'd have, you know, possibly tens. So a lot of service providers, 20, 30, 40 sites. And what you see is a term which I don't like, but I'm going to use it. It reminds me of Shrek. It's like far away land, far edge. But this far edge tends to be a point of your network where we call the pre-aggregation or whatever, and this tends to go to hundreds out to the cell sites, which tends to be thousands or tens of thousands. So the question here becomes, where is the edge and where do I put it? What is the service? And so the analysts in certain cases would lead you to believe that you'll put everything way out here. And I can tell you the answer is not that you put everything way out here, because technology-wise, cost-wise, that doesn't make sense. And we've done a very deep analysis on this. So then the question becomes, where do we go to? So we've kind of there given a very, very quick introduction, but most of the key components of what's happening in the market, what's happening with virtualization, it's solidified, but we've now moving on. Where do we go from here? How do we actually hit the requirements that we actually see? So very, very clearly, you'll see, where do we go? What are the initiatives? What are we going towards? The next thing I'd like to do is answer some of the questions I brought up at the end is, what are the services and where is the edge? And so just very, very kind of high level, but there is a lot of detail behind this. This is of interest of what these things are. As you can see, I do walk. I've actually worn out shoes. I go through a phenomenal amount of shoes, but I will try and stay still if I can. So the first thing is you have to categorize the services. So we did quite a deep analysis and looking at different services. What you now tend to see, you see network to user, you see user to network, you see certain services as well that actually is user to user, which starts to get quite interesting. But in general, when you actually look at these services, they can be briefly categorized into three major areas. And unfortunately, and this is a term I'm allowed to use, seemingly I've gone through about 3 terms, and this is the term I can use. As you go down, the service gets funkier. Seemingly funkier is a word I can use. I was using another word, which I've been stopped from using. But as you go down, a lot of these services tend to be pretty boring to getting to very interesting. The problem here that you will start to see is that at the top, infrastructure use cases doesn't seem to excite people. And the infrastructure use cases tend to be things like virtual BNG, virtual CMTS, remote PHY, the technologies in cable or wireline, but also very, very interesting, and I bring it up, and people need to know, is the whole thing of cloud RAN and virtual RAN. Now, to people here, you mightn't be radio experts, you mightn't even work in the area, but you need to be aware of what's going on, because very, very clearly, this is going to have, and I'll summarize this later, what is going on here is proving as a baseline or as a platform for what's going on here. As we go down, we go very much to branded services, streaming services, content. So they tend to be SP branded services. We're beginning to see things like live TV, CDN, but also we are seeing a number of operators we're working with, things like virtual reality, augmented reality type services. But very, very key as we go down here, services to the business are vertical markets. I would say vertical markets. And what you'll see down here is things like gaming, connected cars. I would make the statement, as we go down here further, a lot of people like to talk about these, but these ones tend to be a lot more real. So there's a lot of talk about connected cars where we're going, but a lot of those is the marketing that actually exists that could be in the future. What you will see is an awful lot more solidity around the services that actually sit in the top. And today in general, what we're seeing is very much a lot of these type services tend to be mobility, but they tend to be connective. What you'll tend to see is a lot of these services are still very, very centralized in their nature. So they tend to be very much around, where's the central regional data centers, peering, maybe in a lot of cases, or some cases going towards a type of cloud type environment. So still today, they tend to be very centralized. We do see some capabilities where you're actually looking at a very distributed instance, and most of these would be things like virtual CPE. So I think a lot of people here may have seen some of these capabilities where you're actually pushing things like virtual CPE right out to what they call the branch. But the question then becomes, is this model going to change? Do we see this model changing in the next 6, 12, 18 months? And then what are the kind of crucial factors that will decide that this will change? So again, the real question that we will have to ask is, what could be deployed here? And the question we added, actually we didn't realize, we're not that quick, but the question we added, which is very key, is who owns it? And you may say, why do you care who owns it? It makes a massive difference, because a lot of the times, and you'll probably know this better than I will, the people who own these type sites tend to be fundamentally different to the owners of these sites. And what you have within the actual SPs at the moment is a lot of times, you know, who's going to control it? Who's going to own that site? Who owns the virtualization platform? Who owns the network? Who owns the VNF? And it's a very critical factor. Who guarantees the SLA? Hence why this question was asked. So we started initially thinking of what would be deployed, but it's actually very clearly ownership becomes the biggest question here, not what's going to be deployed. Why? What were the reasons? So we went to about 30 different operators, and we took a lot of the information of why would you distribute, trying to do a balanced approach to distribute or not. Very clearly, up at the top, and this is a quote, is latency is money. That's actually, you know, a very senior CTO of one of the largest SPs in Europe. Latency is money to them at this moment in time. To finish first or to finish third on a performance testing is massive money to them. To be last on that list is catastrophic for them, actually. Reduction in backhaul. We are beginning to see it in Europe. Not that backhaul is restricted, but a number of people are beginning to see the evolution from 10 gig to 100 gig. How much would it cost? Is it possible? Is it feasible? The US is obsessed with this because in a lot of cases they don't own their backhaul. In Europe in general, we own our backhaul, but it's about how do we stop the migrations from this sort of evolution to the next. Location awareness becomes very key. Very key as well, especially when you have large operators who need to keep information local. And then there's other things lower on the list, lower battery life, regulation, compliance. But one that actually is starting to really come up the list, and it did start low, but in the last few months it's come up, is blast radiuses. A lot of the time today, there's very specific SLAs, very specific capabilities, and by reducing your blast radius, you're actually seeing an advantage. There are disadvantages to deploying in more distributed parts of the network. And the disadvantages, it is operationally more complex. You have to state that. If you're putting intelligence further into the network, there isn't a magic dust. I love this sometimes. People have this magic dust. They go, oh, it's easy. It's not. It's operationally complex. There is a higher cost. You are starting to put different equipment in different parts of the network. We are seeing concerns around environmental issues, around security, you know, and very specifically, you know, you will also be looking at newer technology. And with newer technology, you have the maturity issue that we've had in NFV as well. And that is a fact of life. We have started a number of projects in EMER now that they call them CO transformation, but it's really about taking a site that traditionally was kind of like a class 5 switch site. I don't know if that's a term that people hear, but or an exchange we would call in Europe. And then they think it's the automatic capability, we'll turn this into a data center. And that sounds great in theory, but thankfully I spent years in these places, and then you realize there's actually things, very physical things. We love talking about virtualization, but there are physical things that are an issue. And physical things, the power is all wrong. You know, when you look at the power capabilities, you look at the floors, the racking, the stacking. When you actually looked at the depth of the racks, there is physical things about it's not as easy to take them from centralized data centers to go to distributed data centers. And then very much about scaling power, how power it needs to be met. But then the questions you ask yourself is, what do I do with these sites? How do I scale them? Do I use all of them? So, for instance, we have one operator that has CO sites today. He has maybe 600, 700 CO sites. In honesty, he probably needs 70, 80, 90. What does he do with the other 600? So these are all the questions of, it's not as easy as saying we'll put it in these parts of the network. I'm going to do it here and I'm going to do it later, but this is one key element. Just remember, when you look at them and you look at these network data centers, they are fundamentally built differently. And if I leave people with one message today, this is very, very key. So if you look at traditional IT data centers, they tend to be very, very large scale. They tend to be east-west. They tend to have legacy. They tend to have new NFV. They tend to be multi-tenanted into the thousands. So the multi-tenancy is a key component. And they tend to be based on technologies such as VXLAN and EVPN. Anyone that's worked in data centers will realize that's massively how these things are done. And it comes back to a question who was asked yesterday. Why are we doing some SR stuff now in relation to what we're doing at NFV? This is the answer why we're doing it. You look at network data centers. These tend to be body network guys, very much integrated into network. It tends to be services that are very complementary with layer 3. You tend to have a lot of north-south traffic. You tend to also have multi-tenancy, but lower scale, normally tens, maybe hundreds. And what you very much do is you will see a preference towards a network-type protocol. Network-type protocol being MPLS, or as Jacob explained this morning, segment routing type capabilities, segment routing V6 as you go forward to get scale. And they tend to be very, very specific services. They tend to be NFV type services, or VNF type services, or CNF. People are, with that term, it's container-based services. So very, very clearly, you'll see that how you build them will need to be different. So what we did is about over 12 months ago, we started this program where we went to about 16 of the top SPs EMER, and we kind of went, what are the services? What really are the services? You know, we all hear the marketing. We all, we see connected car, wonderful, connected hospitals. I really want to do an operation over a radio net. What are the true capabilities? What do we really, really look at? And so what we did is we picked what were the top 6, 7 use cases. We cut it to 6 in the end. There were 7 or 8. There is quite a lot of information, but we actually looked at the infrastructure services. We looked at things like public cloud hosting. So taking things like Greengrass and putting it on the SP network. Does that make a difference from a very centralized employment? Looked at things like augmented reality, gaming. Had a great time. I had to grow a beard. I had to put a hoodie on. We actually interacted with some of the gaming community, and we chose 1 or 2 gaming companies to actually come and work with a lot of SPs to see what is the performance that's really needed. And again, things like connected car, autonomous vehicle, what's the reality behind it? Because they claim an awful lot, but what is the actual reality? And again, very, very clearly when you look at these, as you go here, as you're more centralized, latency increases, backhaul bandwidth increases. As you push out, obviously the operational complexity, but the overall cost increases as well. So you have to come at this from a very balanced point of view. And again, the key question was, where is the sweet spot? It's very easy to say the sweet spot is here, but you have to balance up many different things. Where is that sweet spot for the services on offer? Again, there's a 250-slide presentation. Be thankful I saved you from this. I'm a nice person. I could have killed you, but I said, no, I'll put it into 1 slide. But it's still very interesting. When you look at the services, what were the things that really started to jump out? As we spoke of earlier, in EMER in general, because we don't really go for the bump and wire mech, the CUPS use case starts to come very much prominent. CUPS being control user plane separation, taking your user plane, distributing it, and this is how you get that session termination, be it a BNG, be it a virtual EPC for mobility. You push that point out in the network, so you separate those 2 things. Very, very clearly, Virtualized RAN was starting to be very topical for a number of people, working in the background. But I bring it up and we do a little bit more on it later because this is turning into one of the key use cases to justify this whole evolution. So even if you don't understand, I come from a radio background. I was in Ericsson. As I say, I'm fully recovered now. I'm all right. I'm okay again. But very, very clearly, this is forming a basis for how some of this evolution takes place. And then very much as you go on, we very much looked at edge, things like edge CDN, mobile wireline, but then we try to say, what is the true benefit of placing some of this intelligence at different parts of the network? It's very easy to say, my gaming app needs 5 milliseconds. You know why? Because you're kind of guaranteed it will perform if you have a 5 milliseconds. But what we start to do, well, what happens if it's 10? What's happened if it's 20? And you'll be very surprised with some of the results. Again, very high level here. You'll actually see that the performance doesn't degrade at different parts of the network. So what we then realized very much as well, and I'm stating the obvious here to a lot of people, it's very, very hard for us as Cisco or even the SP to be the sole people involved. So what we actually found out is as we went through these use cases and we worked with a number of things, you actually do need to have an ecosystem of say, in instance, with the CDN providers, you have the CDN providers, you have the content owner, you need the consumers, you need agreement as to where they'll actually push some of their content. In this case, for instance, the gaming, we had to work with gaming companies, with the service provider and ourselves, an agreement on what parts of the network. I think some of this is quite self-explanatory. But what you'll actually see is that one of the key use cases that I mentioned earlier was very much around how this mobility and this mobile market was going to go. So to very much kind of at a high level, what we began to realize is that the networks and the radio networks were very dominant in a lot of SP's minds. And as we actually saw, we are now going towards from having a thing called an E node B to a very centralized kind of core gateway to now very much looking at possibly front haul networks, mid-haul networks, and backhaul networks. And again, what we are starting to see, and you'll see MWC this year starting to come out, is that we're now breaking these components up. And you don't need to know what these components are, but the radio unit is like an antenna system. You then have a distributed unit and a central unit, which is really the processing. It traditionally was being called the BBU, it's the baseband unit. But what you need to know is that, very clearly, there's going to be functions at different parts of the network, and very, very clearly, some of the latency requirements are exceptionally stringent. I say exceptionally stringent in general. The budget between an RU and a DU is 250 microseconds. You'll actually find the transport is about 100 microseconds. Now, to anyone here that understands microseconds, by the way, the speed of light in the US and Europe is different. I went into a call, they said, through our fiber it goes, la la la, and I'm going, that's different, but you know what? You win some battles, you lose some. I wasn't going to fight that. But seemingly, it's different. Our US colleagues, sometimes I wonder. But very, very much, if you're looking at 100 microseconds, in Europe in general, that's somewhere between 11 to 13 kilometers of fiber. So that in itself changes how your architecture looks. And that's why I bring it up here. It's one of the big use cases that fundamentally changes how an architecture evolves. You mightn't like this, you mightn't believe it, but you do need to understand there are very, very stringent requirements here. And I bring this up specifically because people need this will be very hard to change. Some people are saying, oh, they'll relax that. They won't. There's this very, very stringent technology reason behind this. And hence why we tend to put a lot of emphasis on a thing called Open vRAN, very much working with a number of what we would call the smaller players to see how these technologies. So you will see at MWC, things like Rakuten I mentioned earlier. They will be launching a network next year with the likes of Altiostar, the likes of a number of others, to actually get full end-to-end virtualized RAN, but having it in a very distributed part of the network. And we'll actually show in a minute what this. So this is really beginning to get realized as to how this is going to be done. This slide may look simple. It doesn't look simple. But this slide was the end of many fights and many analysis with service providers. And what you will begin to see, and especially up here, these are figures that have come from quite detailed testing. So very much around latency. But what you will see is, while in the theory on outside they need very, very strict latency, what you will see is most of those, even the things like augmented reality, virtual reality, is in the region of 20 milliseconds. And that is quite key, because when you look at it, you kind of go, these are, in general, what we saw was 85% of what people were looking to deploy. It's very much, you know, do I build my network for the worst case scenario, which is down here. Now, most of these ones down here are ultra reliable low latency, which don't tend to be ones people are going to launch in the next year or two, but definitely for the ones that were being planned, you can see here, there was a magical figure beginning to come out of around 20 milliseconds. And so what you tended to see is that where in the network could I put these intelligence that actually justified the investment, but also met the requirement of the service. And I know this is quite I like maths, as you can see. All these slides are shared, and there are more complex ones. But what you'll really begin to see is that this is an area of the network that is looking like the sweet spot. So very much when you look at here, an X in Europe in general and tier ones tend to be 4 or 5. So when you look at it, you're saying there's a point of the network where I'm looking to see 10 to 20 milliseconds, where will that be met? And in a lot of cases, it's at this point of the network. Don't make the mistake. The latency is all the way from the app to the user. A lot of people say, 20 milliseconds, my fiber, I can do that direct fiber. Alone on your handset, there's a 2 millisecond. If you go through a virtualization platform, you can get inefficient virtualization platforms that in one case it took 5 to 6 milliseconds just to get through the vSwitch. Not ours, but someone else's. But these are the things you have to take into account. So look at it from end to end. So in essence, where we really went to was really about what point of the network do these services need to look at? What were the requirements? So very, very clearly, we see the sweet spot definitely becoming in this point of the network. So it's the aggregation, the MSO, the head end, the metro, whatever you want to call it. The general term we're using for that is edge. So this is definitely becoming the sweet spot. So from going traditional centralized, how do I get compute to this part of the network? So this is really starting to show this is happening. This isn't something in 12, 18 months. This is happening now. We are doing this now. So already we're saying, how do we re-architect these to actually support compute and services from end to end? The one big caveat to that is that there is one very, very major use case that's beginning to get traction in EMER. I would say Asia Pac is a bit ahead of us, but definitely in Europe, we're beginning to see what do I do for this virtual RAN. And the virtual RAN, by the nature of splitting RU and DU, is definitely coming out to this point in the network. And I'll give examples of that in a while. Why? It's mostly down to scale. It's mostly down to latency figures as well. So very, very clearly, most services here, it's a balance between blast radius, it's a balance between resilience, it's a balance between latency, it's a balance between cost. Remember, cost increases as you go out as well. So we are seeing this based on the 16 operators. There are tier 1, tier 2s. We are seeing this as but the use case specifically here is virtual RAN in that point of the actual network. And so what you tend to see is we go from this example, which I would say is in the last 12 to 18 months, to this example, which is what we plan to see in the next 12 to 18 months, is that you will see a lot of the services that traditionally are here beginning to move to the CO part of the network, and specific services moving out to what we call the far edge or pre-aggregation, with again, certain services as well moving to the edge. And that's the example I gave earlier, is that definitely for the ultra reliable low latency services that you saw at the end there, A number of SPs are beginning to work with us and say, I'm actually not going to put them on my network at all. I'm actually going to put that on the branch or the enterprise. So very, very key. I know I've summarized this. There is actually, as I said, 250 slides behind this, which, as I say to many people, I have to listen to my voice all the time. You could imagine how I feel. But very much, you know, this is where we're going. So we've looked at the market. We've looked to see what the market is doing. I've shared with you at a very high level the analysis we've done for the last 12 to 18 months and the services, the requirements, where they're going in the network. What are we actually doing? What's Cisco doing to get this together? What are we actually doing from the point of view of end-to-end? You'd be glad to know this is the last section. But I am taking you on a journey of what we've done. This is the shortened version, hard to believe. But there's 4 major pillars. There's 4 major pillars in this evolution. We have tended in SP in the past to go with a transformation without bringing the services with us. So we've tended to launch technologies without having a use case. We've tended to say, well, I'm going to virtualize all these things. Then you go, oh, really, I don't need to virtualize them. What we want to do here is definitely start with the app or the service evolution. Start with the service. Start with the app and look at what's happening. So from the point of view of the app, you know, is it going to be decomposed? Is it going to be disaggregated? Where does it need to go? What does it need to support? Are these apps going from traditional monolithic, I hate using that word, but that's monolithic type kernels, to a more container or cloud native based capability? So these are the sort of capabilities, but very, very key, where is it going to be placed? Where does it need to be placed in the network? Remember we said experience, customer experience is becoming paramount. Remember we said 5G is a lot of distributed intelligence. Very, very key. Once you've that discovered, what is the virtualization platform? What does that virtualization platform need to do? What workloads does it need to support? But also, what's the consumption model? Very, very key question. Is it virtual machine? Is it containers? But what you'll begin to see, if you look a step and look at some of the real people looking at this, bare metal as a service is become very popular. Function as a service. So really, an app developer or a developer, what does he really want? He doesn't care about the infrastructure. He doesn't care about distributed, centralized, wah. They just go, I don't care. But what they do care about is, where does my function go? What SLA do you offer on my function? So an app developer now can go to the point, you develop an API and you say, I will guarantee that this will have a performance of X and a latency within 5-10 milliseconds. That's different. They love that. And you hand them an API. And that's where a lot of places are going. And then you go, what point, you know, what do I need to do at different points of the network? Does it be centralized? But very, very key, and a point brought up yesterday, what fabric am I going to use to stitch all this stuff together? So we talked about all lovely here, there, centralized, distributed. How do I actually, what fabric or what technology am I going to, you could call it, I hate this word, I'm going to use it, I promised I wouldn't, but stitch it together. I hate stitching. You know, what's the fabric? What's the end-to-end capability? How do I actually make sure that the data center, the WAN, the distribution, they all work together? And that's a very big challenge. That's not so simple. And again, how do I make sure that there's consistency, consistent policy, and also what you'll see later, how do I automate this? How am I going to automate this? And then the last one, right up at the top, is how do I orchestrate this from end to end? How do I make this fully automated, orchestrated, but also, and what I led to earlier, how do I consume it? You know, because the consumption of this becomes a very, very key component of where we're going to go. So just to take the first one, I kind of stated this already. When we look at this, the services that really are proving as the baseline, as the justification for this evolution, is the less funky, as we said, the funky is the word, I have another word, but less funky services, things like virtual BNG, virtual OLT, virtual CMTS, you know, these sort of use cases are very much, and as I said, are virtual RAN type capabilities. What I would say is we are working with many operators on these use cases, but it's very, very hard justification to do this evolution based on these services. As funky as they are and as good as they are for marketing, and we all love to talk about them, these ones, and I've been through a number of this analysis, it's very, very hard to justify. But if you have a baseline upon which you can build a platform and support these, you are really on the road to something good. So, what are we doing? So, very much we are looking at things like cups. So, cups becomes, a lot of people wonder why we do cups, what's the advantage to cups? The key advantage that you'll see in a cups environment is very much you can actually push the termination or the end user termination further into the network. And by doing that, you improve the customer experience. So in all cases in EMER, when we look at this, it's about centralizing the control plane, getting common control plane. In a lot of cases, you'll virtualize it. It's very easy to virtualize. And even for wireline or mobile, you push that user plane very far into the network. So we already have a number of POCs, a number of kind of instances at the moment where we're beginning to look at cups as the means to do MEC-type services. I use that word very carefully, but that is the most implementation that you'll see in this environment from end to end. I would really ask people, understand what virtual RAN is trying to achieve. They make it as confusing as possible. Try and at least, to a lot of people, understand that there are different splits. Those splits will give you different capabilities. And again, looking at the splits we're mostly concerned with today, especially with 5G, but also look at 4G, is these split 7 and split 2, high-level, low-level splits. I know they try and make this quite complex, but really what we need to understand is with these splits, it gives rise to potentially a front haul, definitely a mid haul and back haul. And I'll give you an example of what we're seeing in a minute. But that then gives rise to the entities of the RU, which is the remote unit, the distributed unit, and the centralized unit. This is like a physical antenna system, but you're going to dumb it down. This combined together has been split. The industry accepted that the central unit would be virtualized. What the industry didn't accept, and especially the big radio players, is that this would be virtualized. What Rakuten and Altiostar are now going to prove is that these elements can all be virtualized in a scalable manner. And I apologize to anyone that knows this very well. I'm not trying to, but I'm trying to give you the key messages of what came out of MWC. So apologies if I'm understating. Not everyone will come from a radio background. So, but that's very, very key, because all of a sudden, this was a very proprietary part of the network, tends to be dominated by a couple of key areas, and now all of a sudden, it's going to become more open. How we put the RAN and the transport, how we do the virtualization platform becomes very, very key. And then the question you should be asking yourself is, right, how do I build on top of this? What other things do I do? And that's what all the operators looking at this. The justification for this alone is maybe, but where does this take me? And that's what all the operators want to know. What presence does it give me? And again, I'm going to leave this in the slides, but in EMER, we have multiple models. We have a model that most people would start with. It's called distributed RAN. It's where they put all those three elements in a distributed manner, like they do today. But what you will see is we have a number of operators who are beginning to look at both virtualized control plane, the central unit, virtualized distributed unit. If you're just user plane functions UPS, but they're already virtualizing that. But what you can see is already in the phase 2 of kind of 5G rollouts, but also 4G. That's the key thing. This actually now applies to 4G as well. And even in fact, Rakuten, it is 4G they're going to deploy like this, going to 5G. You can see these models are already in consideration in EMER today. And just then, To give you an example, and I can actually state this because it was announced, this is the Rakuten model. What you really are talking about here is a model where they will go to, tens of thousands of sites. To do the vRAN, eventually they need to go to about 3,000 sites. That's maybe 2,500, 3,000. So remember, this is the kind of far edge, that term I don't like. It reminds me of the Shrek movie, Never Never Land in the Far Way. The far edge is very much here. They'll go to about 3,000. And then you'll have a number of regional data centers where they'll put some of their centralized services, very much going over an IPv6 type backbone. So again, we can see the realization of this actually happening very much as we go into next year. Edge computing, fully virtualized stack from end to end. So again, the reality, this is happening. And just to take one other example of work that's ongoing at the moment, and I didn't go into this in much detail, but I will mention it in a minute. We also have infrastructure services that have been completely rebuilt from scratch. So if anyone's familiar with cable, not everyone here will be into cable, but it's a good example where we've taken the software, and because we want to have a kind of a continuous integration, continuous deployment type architecture, we want to be able to scale individual components up. We want to be also separate components. What we have is a complete rebuild of a traditional CMTS that has been completely containerized. And this gives you an example of the tooling, both Cisco optimized, but also open source components involved in doing that. And I think it's very good that you understand that already, you will see this year, like in the next few months, a completely containerized traditional kind of capability that, yes, we will put enhancements on, but there's many things here that you would be familiar with. I'm sure everyone here has looked at Kafka at some stage. I think people here would look at things like Grafana as a kind of as a way to model or to show how the performance is going. But then looking at the individual components in both the control plane and the user plane in relation to containerizing. And so while the industry talks about this could come, this is coming. This is here. The one thing I would say is I don't agree with the analysts is there isn't, again, this magic dust that everything will turn from VM-based to container-based overnight. There seems to be a magic dust that some of these guys have introduced. It's not going to be like that. It's going to be a hybrid between supporting both virtual machine and containerized as you go forward. And that is the problem. That is both the good thing and the bad thing. So just to give you an idea, what are the major things? We're seeing definitely CUPS. We're definitely seeing, Cloud RAN coming up. We're definitely seeing the going to fully containerized or microservice-based elements, and the support of these is very, very key. Okay, so we've kind of looked at the services, the apps, what's happening, the reality of what we're doing in EMER, and this kind of leads on from what my good friend, who I momentarily forgot his name, Callie, such a good friend, I got a little stuck with his name. What are we doing in the virtualization platform? So we've looked at the first pillar. We've looked at the service, what's happening with the service, distributed, centralized, decomposed. What's happening with this? And what you really see at a very high level is traditionally virtualization in NFV, even though people don't state it, is a very centralized architecture. So most of the NFV deployments today tend to be quite centralized. But as we try and push out, and as we're kind of looking at these, how do I get these elements in different parts of the network? And what's the requirement? Again, in Cisco, we are working very heavily. If we don't do it ourselves, we work with partners very heavily in an open source type environment. And so we are very heavily involved in what goes on with things like OpenStack. So while we ourselves, don't develop OpenStack, we do a lot of contributions, as Callie spoke about yesterday. We work very closely with some partners, and we actually have products that we have, like Cisco Vim, that are OpenStack based. But how do we address some of the issues in relation to OpenStack, and especially in relation to, could I really justify a full instance of OpenStack in a more distributed part of the network? And they're very, very key questions. So today, this is really what you would see with an NFVI type implementation, or in fact, an NFV. And this is what I said earlier. We tend to have a platform, an NFVI platform. You tend to have VNFs, and then you tend to have an orchestration or an NFVO capability sitting on top. Now, if you look at it, you'll see, as Kelly showed yesterday, you have management, you have assurance, you have very much the networking, the storage, the compute elements, and then you have a lot of the virtual elements, and in a lot of cases, you will have some sort of controller as well. And on top of that, you will have some VNF manager. So this is the basis by which the industry has developed. This is the basis by which, NFV has actually developed. What you now see is based on the kind of requirements that we've done over the last 12 to 18 months, we've realized that as we push out and as we have the requirements to move further into the network, we have to go from the full pods onto hyper-converged pods, to micropods, to head pods. And what you really are doing at a very high level is we're trying to take the baseline infrastructure needed to support them and squeeze it down. So one of the beauties to what we did initially is we obviously work very closely with Red Hat, but they presented us the software. What we did very early on is that we containerized that software. So 2-3 years ago, we actually took OpenStack, and I was involved in the initial. Poor Kelly had to take it on after me. But we containerized OpenStack, which means doing things like converged compute and storage, or converging the control compute and storage becomes a lot easier. So we reduce the minimum amount of servers. Interestingly enough, edge pod capabilities here, which you talked about yesterday, is really about the control and compute converged with centralized storage. And most of this model has been developed for a cloud RAN type environment. So what you will see is these developments are being done not just because it's nice, but there's specific use case, specific requirements, and especially a lot of people don't realize that there is an awful lot of VNFs today where there isn't need for a lot of storage. Apart from the glance image and a few things like that, why are you putting massive amounts of storage for something that doesn't need a lot of storage? So again, getting a lot more optimized capabilities. But you need to be aware that the industry, whether we like it or we not, is going cloud native. I use the term. Every presentation has to have the word cloud native. If you don't do a presentation with cloud native in it, you don't get your bonus at the end of the year or something. But there is real justification with it. And we are now beginning to see the benefits of it. So things like lifecycle automation is a lot more slick, a lot more optimized. It is definitely more lightweight and fast. The multi-cloud portability is very, very key. So whether you go in a public cloud, whether you go in a full NFV stack, whether you go with something like a KVM capability, you need to be sure that it can be supported from end to end. There is no doubt as well that the performance is a major, major factor. And one of the real benefits that we actually are beginning to see is that when we containerize things like virtual BNG or virtual EPC, what you are finding is that we can put state at a layer, but then have pure stateless capabilities above, which means that we can change, interrupt the stateless capability, and think your mind, how am I going to converge wireline and mobile? If I have state in the bottom layer, whether I'm a mobile subscriber or a wireline subscriber, to have state about them and link those together becomes a real, real key capability. So what we are seeing in the industry as we go forward, we are very much seeing, we've gone from dedicated hardware, we've seen virtual machine, where today we see a lot of people supporting containers, but containers within VMs. A lot of people are confused by this. The reason most people do this is because the overall infrastructure and orchestration is built for VMs. So changing this to a containerized world is very difficult. So what we see as a first step is put it within a VM. You have all the tooling, you have all the management, you have all the monitoring. But what you will see in the next 6 to 12 months is containers on bare metal. And as we look towards this, you will really see the tooling, the capabilities to support this coming along. And at the same time, I would direct people towards here. Function as a service will gain an awful lot of traction because that's how you're going to attract in the real developers, the real apps to come onto your infrastructure. And again, you will see how do I consume it, how do I implement it becomes a key factor as we go forward. I have to put some reality though. A lot of people say container solves the sun, moon and stars. When we go to containers, we lose all the problems. That's actually not true. In fact, I would go so far as to say is containers themselves are introducing some issues. And so please, when someone comes to you and says containerization is a good thing, yes, it is. But please remember, we have key things that we need to support in a containerized environment. Multi-tenancy is very key. Do not allow containerized in a non-multi-tenancy environment. Networking. NFV has been held back today because the networking, things like OVS, things like OVS-DB, do not cut the mustard. I think, call it here in the front, you mentioned things like SRIOV. I was there when this was proposed at the very start. SRIOV is like a 25-year technology where we stitch up basically components to get the performance up. We need to be sure that we can get the networking elements of containerization correct, optimized in such a way that it does not limit the performance. And there are technologies working on. So things like, ability to support NUMA awareness, CPU pinning, all these things, make sure we don't relive the horrors we had in a VM environment. But again, there are other areas, and the bottom one is the most key. Security. Isolation. How do we isolate? With all the security concerns, with all the benefits we see of it, we need to make sure that the security and isolation of containerized elements is absolutely key. Other areas that we are hitting, things like proprietary kernels, having a common operating system to support multiple containers on a single instance. These are the things that the industry needs to solve and get right. And hopefully, with the help of people like yourselves, we will, and we do have solutions. They do need adoption. But this is a reality slide that there are still things that need to be addressed to get a containerized environment working. And just to give you an idea, and I think Callie did some of this yesterday, just as you go forward, and I'm not going to go into this in much detail, but basically we are taking Cisco Vim as it is today, very much a VM-based capability. We are going to position and support going forward a module called CCP, which is Cisco Container Platform, which is very much about supporting a containerized environment. The very key thing here, guys, is there has to be a hybrid. There has to be a way to support both containers and VMs. VMs are not going to disappear off the face of the earth. You do need to simultaneously support them. Definitely as we go forward, we have a capability of actually supporting containers and bare metal. So using things like ironic bare metal within OpenStack to support that environment. But then ultimately, we do see the capability where you have like a manager that will choose whether you do a VM-based implementation or a container-based implementation. So there is clearly a roadmap going forward to support both hybrid, VM, and bare metal, but also very much choosing whether you want just a containerized environment or just a VM-type capability going forward. Key message here is there isn't switching of one off to another on. I hear it in certain places. That's not the reality of how this will be done. So in general, what we hope to see and what we hope to realize is that, you look at your area of the network, you look at your virtualization platform, you look at your modules, and you say, what do I need here? Do I just need containers here? Do I need containers and VMs and bare metal? And that's what we're beginning to see, is that a lot of times it's just containers here. A lot of the times here, when we look at this part of the network, it's containers, it's VMs, it's bare metal as a service, and actually, in fact, function as a service in this part of the network. You need to look at your hardware, you need to look at your packaging, your drivers, and then you need to realize, what lifecycle automation, what stack do I need to support the services that are in that part of the network, and then very much, how do I get these networked? How do I get the common policy? How do I get the tooling? And how do I do this across multiple sites from end to end? Right. Well, Sorry, my mouse is getting, or sorry, the clicker's getting a little stuck here. So this in general is what the virtualization platform will be built like. This is what we're planning towards as we go forward. So we've seen the 4 pillars, the service, the virtualization stack. The next pillar that we're just going to briefly look at, and hopefully it answers 1 or 2 questions from yesterday, is what's the network fabric? Where do we take the network fabric as we actually go forward? And again, I bring you back to this slide. Please remember that as we look at network data centers and we look at these distributed deployments, the requirements are fundamentally different. So what we would say in general is that as you move from very, very centralized deployments, you will have a mass amount of servers. You will have a hub and spoke type environment. You will have a top of rack switch. You will have spine leaf type environments. And you tend to have a separate EE1 element. That's how traditional centralized deployments are. But as you move out, you'll begin to see things disappearing. And most of the time it's due to scale. Most of the time it's due to cost. As much as we're engineers, there is a cost associated with things. I know you probably have someone hitting you in the back of the head about cost. Well, I do anyway. I don't know about you. Do people get hit in the back of the head with cost, cost, cost? I have it all the time. And then as you go out further, and in a lot of cases we see that you'll just have a top of rack switch with a PE. But in fact, as you really go out, some of the designs we're now starting to consider is where you combine the PE with the TOR to go to a small amount of servers. And that's very, very important, because I hope this starts to register. As you go to these architectures, how you build them and how you architect them is fundamentally different. Today, this is how we build them. This is the requirements as we go forward. And so what we're doing is very much about how do we look at it, and how do we look at the technologies, and how do we look at this from end to end. So we take a number of factors. We take the fact that the service requirements are different, but also you have to take into account the fact that the ownership of these sites is fundamentally different as well. The people that own them, the people that run them, are fundamentally different. And what you tend to see is people in this area, the network in general, tend to be more networking people, more MPLS aware, more segment routed aware. People in this point of the network we find are more VXLAN or hopefully ACI type. So what you will see from Cisco is very much when we develop the kind of the NFVI capabilities, very much we now have the capability to support things like APIC ACI and the ability to distribute out further into the network with things like remote leaf, which is like having a remote leaf further into the network, or multi-site, where you have a single APIC instance controlling multiple sites. But also at the same time, we will also support a kind of NCS-based capability, which means you're more network-related, you're running protocols like MPLS-SR, because it meets the design guidelines of the previous slides. So this is very much a transition that we are beginning to see now. And again, the big thing that we are starting to do, and my big challenge today, is very much about how do we make sure that we get this interworking between the data center and the WAN working properly, and how do I get consistency from a policy point of view from end to end? How do I make sure that I can put this together? The beauty to many SPs around the network-based model is that they don't have an interworking function. How many people here over the last 10 years, interworking functions, anyone do pseudo-wire stitching or anything like that? You all have far too much hair to have done. I spent a lot of my life with pseudo-wire stitching, right? Hence lost hair. Interworking stitching, those terminologies fill me full of dread, because how do you get end-to-end SLAs? How do you get end-to-end OEM? How do you provision it from end to end? And hence why using a single protocol, a single fabric from end to end has massive advantage for people in this environment. And again, consistent policy, consistent management from end to end is a key deliverable of this. And just very, very briefly, we have technologies. Even if you're not an ACI, APIC expert, it's very much about how do we go from centralized deployments, pushing out with things like remote leaf, pushing out with things like multi-site to get more distributed environments. But what we're also doing is very much looking at the very distributed environments where today we have these sort of infrastructures where you have your PE, you have your Tor, you have your compute. Traditionally today what you see is a demarc at the PE, and so you're doing VXLAN to here, you're doing SR or MPLS from here out. But what we are actually doing is looking at, at the capability of actually looking at SR or looking at an MPLS and actually pushing it into the data center, pushing it into the Tor, pushing it into the compute. So what you will begin to see is very much about putting that network protocol and pushing it a lot further into the network. And again, what we're even doing today is we're looking at things like OpenStack, at things like Neutron, and Callie mentioned this yesterday, is very much about even using things like ML2 plugins to allow you to do the provisioning of this from end to end. Just so you're aware as well, when we look at these technologies and we look at things like segment routing and we look at virtualized capabilities, there is a thing called FDIO, which is basically a Cisco technology called VPP that actually is helping to get very, very optimized containerized networking as well. So very much as you look at some of these technologies, what you will see is that there is also very much when you look at things like SR, SRv6, we do have the capabilities to support this in a containerized environment as well. So it's very, very key that we're not doing it just for physical, we're doing it for physical and virtual. And then the last pillar that was very, very key, and definitely you'll see some of this with Patrice. One customer called this a spaceship. I don't know if that was a compliment or not. I decided not to ask him. I don't think it was a compliment. I think I need to improve. But this is the reality. We see slides, and they're actually going cross-domain orchestration. It's a single line, and it's like magically this all works. This is the reality of how cross-domain orchestration works, and we have it going today. Very much is that you look at your domains, you look at the requirements of your domains. You could have an SDN controller as such from end to end in each of your domains, but you very much have an orchestration element that does this from end to end. So already in EMER, we have multiple implementations, and I think you're speaking about this later, using products such as NSO, using netconf-yang to actually look at this from end to end, looking all the way from very, very centralized telco data centers, across the transport, across what we call edge cloud, even down to the RAN elements. One of the big things of Open RAN and vRAN is that they have actually defined netconf-yang as the way to provision the CU and DU. So one of the big elements is that that tended to be very proprietary. So when you look at this, the cross-domain orchestration from end to end, you look at a very model-driven approach from end to end. And then finally, one of the key elements that we are doing massive work, and if you get a chance, look at the Mobile Edge X and what they're trying to do, because this is very much in line with what we think needs to be done. We're working very closely, is when you have all this done in different parts, you have the management, you have the cross-domain orchestration, how do we consume it? How do you consume it in a way that the users actually want to do it? It could be app developers, it could be the SP itself, it could be third-party tenants. So what we're seeing here is the development of an API platform that will allow you to actually hand off and provide APIs to do things like network slicing, to do things like, specific functions to specific parts of the network, and is a very, 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 very key requirement of how this goes forward. This is one of the most topical areas today, is the consumption of this from end to end. So if we actually look at it, what we hope to do with the four pillars that's very, very key is we need to look at the service, we need to look at the service requirements, we need to look at the virtualization platform from the point of view of what's the components, is it containers, is it virtual machines, is it bare metal as a service, is it function as a service. Very much look at the orchestration, look at the cross-domain orchestration, look at the capabilities to actually offer APIs in an API platform, and then putting all these things together, you end up very much with a solution that addresses core MEC, but very much is about service edge transformation, all the way from centralized data centers all the way out to the potential edge, if that's where the service is actually located. So you'd be glad to know, just to conclude, the virtualization is on this slope of enlightenment. You know, if we use Gardner terms, we're come out of that trough of disillusionment. We're enlightening ourselves. I quite like the trough of disillusionment. I'm Irish. We love a little bit of disillusionment. There is a change in the market from a business, a customer expectation. We definitely are seeing the view towards low latency, performance application, customer experience. 5G is playing quite a big role in how this evolution is taking place. Whether you believe everything about 5G or not, it is a trigger that we're seeing in the market that is leading to it. The questions you really need to ask yourself is, where are the edge and what are the services? The big question really, where is the edge, is the big question. And then what services am I going to put there? Again, there is a lot of variety, but I would say stick with the services that are going to serve as the baseline. We all love the funky services, they look well, but stick very much to what are the baseline capabilities. And then when you look to build a virtualization platform, look at the 4 pillars. Don't look at just one, you need to look at all 4 pillars of how they actually all work together. So that's it. That was 90 minutes, it was quite long, it was after lunch. But if any of this triggered interest, come back. There's a whole load of detail behind this. I know this is meant to trigger where we're going, what we're doing. We do lead a lot of what we're doing here. This is a bit future looking, but a lot of things I spoke is what we're doing today and what we plan on doing. Quite a bit of detail, but I want you to go in and at least think about what we're doing. There is a plan. And it is in the next 6, 12, 18 months, we are spending a lot of time with a lot of service providers, Tier 1 and Tier 2. This is not just 1 or 2 operators. You know, we've involved 16, 18 operators in the plan of what we're doing here. So if any questions, please come back. Thanks a million. Thank you.
Okay, so
I'm bang on time.